In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. Problem 10, we're asked to draw the product of each reaction. In order to do this problem, I highly recommend you follow the sample problem 9.2, which is to draw the curved arrow reaction mechanisms. This will help you identify what's negative, what's positive, what's the leaving group, what's being replaced, and so on. When you're dealing with sodium hydride, the sodium is positively charged. It's a +1 cation. Hydride is a -1 cation. Okay, so hydride is a base. It's going to deprotonate this alcohol. In order to deprotonate the alcohol, it's really necessary, it's absolutely critical to draw the oxygen-hydrogen bond. Okay, so I'm going to draw a little OH there. Now we can draw the curved arrow reaction mechanism. The hydride is going to come in, deprotonate the alcohol. Okay, so you'll notice how we need to show this bond so we can show the second arrow here. And in so doing, we can write the products of the reaction. We're going to have a negative charge on the oxygen. Okay, I won't draw all the other inorganic stuff. Now, we do the same thing down here with NaNH2. Na is a positive, spectator ion. We just put a plus there. NH2 is negatively charged. Okay, and again, in order to draw this acid-base reaction, it's really critical to draw that H out. Okay, so if you see this on a homework, an exam, something like that, it's necessary to redraw the organic molecules so you can see that OH bond there. Let's go ahead and draw the curved arrow reaction mechanism. This negative charge here is going to act as the base. We're going to point it right to the hydrogen, and this OH bond is going to break, and the arrow points to the oxygen. So the oxygen is going to become negatively charged. So this makes the alkoxide once again. So let's draw the 5-membered ring. Draw this branch here, and then draw O-. Now in this next reaction, once again, we want to draw this hydrogen out. Okay, so let's go ahead and draw that in. Okay. We've got a couple things here. So NaH, that's again going to deprotonate the alcohol. So let's put the positive charge and negative charge here. Let's switch to the blue pen for the curved arrows. So this negative charge from the hydride is going to serve as a strong base to deprotonate the alcohol. And let's off to the side here sketch what we have. We have now this alkoxide, and we have 1-bromopropane here. So let's draw that out. Okay, and we have this negative charge here, which is a strong nucleophile. Alkoxides attack alkyl halides, as we know, in the Williamson ether synthesis. And so we're going to redraw this molecule here with the appropriate number of carbon atoms and attach a propyl group off the oxygen. Okay, so here's my oxygen, and then I have 1, 2, 3 carbons. 1, 2, 3 carbons. Okay, so that's this ether. Now here, this question, well, they give us the formula of the product, and well, what's going on here? Let's think through the mechanism once again. We want to draw the OH bond. We want to go ahead and draw charges so we can figure out what's going to be doing the deprotonating. It's the hydride once again. So this hydride is going to pull the proton off the alcohol and give us an alkoxide. Now that's not the product because this formula doesn't have bromine in it. Now this is a nucleophile, right? Negatively charged oxygen atoms are called alkoxides. They're nucleophiles. And this is a alkyl halide or a halogen, which is a good leaving group. So what can happen here is the negative charge can actually adjacent to itself, attack itself, kick off the halogen, and what you'll get as a product here is the epoxide. Right? If you haven't seen that before, it might be very new to you, but now that you've seen it, it's more recognizable. You can form rings from alcohols and alkyl halides. So for example, I won't work this out for you, but what product do you think would form there? Okay, thanks for watching.